Alright, time for another DraftPhysics.com video presentation. Unfortunately, I have to do this a second time because the yeah, the software failed me. Anyway, so this is mostly for PhysicistMichael if he can watch the video. He does watch a lot of my content, so to be fair, I appreciate that. So I have played this, 100 times in videos. I'll just make the quick point. So this is the infamous, in my opinion, free momentum experiment, where we plow 100 momentum into a system, and because we create left and right energy out of it, that somehow we can say that this cancels that. So even though I put 100 in, I get 133 going that way, and I get 33 going that way, I can create 166 out of 100. My argument is that's not how motion in the universe works. You can't create free motion. Any motion has to consume something else's motion. Newton's cradle, bang, bang, same motion. You can't make more motion. You can't make more mass and velocity. You can't make more momentum. It's that simple. Anyway, and it all goes back to scalar and vectors, and yes, these are just arbitrary assignments imposed on these concepts somewhere in the 1800s. There's no experiment that caused them to do that. It was just mathematic coherency that they needed the math to do it, so they imposed it on the math. This is almost like Diracian kind of stuff. We can do a real abstract, bizarre thing and create antimatter, and it helps us mathematically. But does it really help you in understanding reality? I would argue not even close, but anyway. So I'll point out, this is, one of the reasons. I mean, obviously I don't see anything coherent about mv squared. There's nothing coherent in the history. There's no evidence that I see that's dramatic or decisive or even reasonably understood. I mean, things like they've never shown it to 4 times the fuel for twice the speed. It's clearly a misunderstanding of gravity that caused Leibniz to believe this in the first place. He thought gravity was a per foot force when it's clearly a per time force, blah, 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 blah. Lots of good arguments, and then you look at an experiment like this and it just overtly screams at you, shenanigans. Why should I believe this? So we're supposed to believe that this cart is twice as massive. Now it seems logical. The carts are same manufacturer, same grooves, so this cart would be twice the length. They usually make them that way, twice as long, 3 times as long. They don't make them 1.76 as long. So there's a glaring deficiency in the sense there's a little weight here. There's not 4 weights on here, right? We assume there's 2 on this one. But let's just go with what's on the one side, make it simple. So one weight. It's supposed to be twice as massive. It's got to have 2 weights. This one's got 2 springs. This one's got 2 springs. Well, this one needs something to account for the 2 missing springs. This one's got a flag to go through the detector. This one's got a flag. There's only 1 flag on each one. Another failure. And then we have this special little blob of clay. Now, the clay was made as strips that usually stick across the surface to make the cart more balanced. And now it's been smushed and crushed and blobbed up here. No clay at all on the other cart. So it's missing 4 clumps of clay. So there is reason to doubt. This is suspicious looking. You'd have to concede that if you're doing the experiment, you really don't want it to look this suspicious. I mean, if you were a fair cop, you'd have to concede, yeah, this looks guilty. Doesn't look quite clean and pristine. Alright, so we'll play a tiny bit. We'll play the experiment since we're here.
Okay. You ready? Yeah.
So 100
There we
in,
go.
100 going in, 133 coming out one way, 33 coming out the other way. Okay, for a total of 166. So I made more objects moving in the universe than I started with. Okay, to me, not too good. Not very capable of being consistent with the reality. So I'll speed up the math part, and then we'll get to the real subject.
Now comes the real acid test. 1, 2, 3, 1, 8, 6. 1, 2, 3. And what is the last one? 3, 7, 5.
I was going to say that.
Okay, let me be lazy, and let me use my calculator.
Yeah, but the last time we really fucked up.
375 divided by 3. I could have done that by heart, of course. This is
Yeah, last time we did that, I got the wrong
0.125.
answer.
An amazing agreement. Amazing. Only 2% off, less than 2%.
So the whole point is yes, this is amazing agreement, and the experiments are never that perfect. But you know, obviously, if the important point to make is if the mass is much less than twice the mass, then when you do the experiment, you have every expectation of having momentum in the other direction because you have very little momentum coming back. There's very little bounce, so that means the object you threw the rubber ball at, so to speak, must have moved. And it moved a substantial amount. And the only way you could move it a substantial amount is it's a lot lighter than he says it was. Then momentum is conserved. So if I am correct and the cart doesn't weigh twice as much and weighs maybe 50 grams less than twice as much, then these numbers make perfect sense with 100 in, 75% this way, 25% that way. Well, it's really 2/3 and 1/3. So it's 66 this way and 33 that way. So those numbers become rational if I'm right that the carts aren't the masses he claims. That would be exactly how you'd expect the experiment to come out, both if you're using kinetic energy theory or if you're using momentum without vector subtraction.
Now here, 0.186 times 2 divided by 3, 0.124. I can't believe it. Less than 1% off. So you see in front of your eyes that we were able to create something that was indeed extremely close to...
Yes, and the question is did you do this creation in a scientific way or did you do it in a religious propagandist way?
Elastic collisions, in spite of all the problems that we have addressed, and that, of course, there's always some loss of...
I mean, from my perspective, this is a Jesus walking on the water kind of experiment. I mean, it's a pretty bold claim that you can make free momentum, and the experiment should look better than this.
Kinetic energy. But it's so little that it doesn't show up in these measurements. Now, I want you to have a sleepless night. I want you to think about the following.
So all of this is based on this concept. It's not really a kinetic energy theory. It's just their momentum doubling theory. So they think you can put something in with a momentum and you can get a maximum of twice the momentum out. So in this brick wall example, this is the maximum. If I made the brick wall yield just a tiny bit, then I could theoretically say I have 100 going in, I'll get 199 coming out, and I'll get a full reflection of 99, an almost complete reflection of 99. So I'll end up with 300 momentums. I put 100 in, I get 300 out.
If you can't solve it before the night is over, then I really think you should lie awake. Here is the wall. Here's a tennis ball that comes in with a certain mass n, and it has a certain velocity v, whatever.
Okay, I will put the move speed back to normal, and maybe increase it a tiny bit. It does seem a little low here. All right. So we have a brick wall. We're going to put in our 100 momentums again, and we're he says tennis ball, but we should say very elastic hard rubber ball, for which we have an expectation that we might get 95% or 97% of the energy back.
But it is. It's a nearly elastic collision, and it bounces back.
So these words are all word play. Okay, the word elastic doesn't mean too much because it could be elastic in different ways. Can be elastic in storage, and it can be elastic in that it doesn't accept anything. So it's a little complicated. And so the word super elastic is used when you augment the object with a spring, for example. So the experiment he did with the carts was super elastic. The carts themselves should be capable of duplicating the experiment. They're elastic. They should be able to. They can perfectly do the Newton's cradle. They can just hit the metal and exchange all of the energy. So the spring is being added for what reason exactly? You already have an elastic carts. Why are we adding the spring? Well, because it doesn't work without it.
Back from the wall. And we all know that if it's a nearly elastic collision, that it comes back with the same velocity. Kinetic energy is conserved. All the kinetic energy is in the tennis ball. Nothing is in the wall.
Well, so there's no point in saying this, right? It's kinetic energy is made out of mv. So wherever we just follow the mv's, there has to be kinetic energy wherever objects are moving. So that's kind of ridiculous. But his argument is that somehow we vector multiple, say that we lost all of the energy of the tennis ball because it's canceled. This way got canceled by that way, so there can't be any momentum, which doesn't make any sense. It just doesn't make any logical sense to ever talk about, in my opinion, okay, the fact is that the scalar kinetic energy is made out of momentum. You can never have zero momentum and positive kinetic energy. It just doesn't make any sense.
The ball has an infinitely large mass. But the momentum of this tennis ball has changed by an amount 2mv. That momentum must be in the wall. It's non-negotiable.
So it's non-negotiable from one narrow perspective, but it's clearly negotiable from reason and logic that if it's not moving, how could it have momentum? Because the definition of momentum is moving the object. If it's not moving, you can't have momentum. So clearly it doesn't make any sense.
Because momentum must be conserved. So now here you see in front of your eyes a case that the wall has momentum, but it has no kinetic energy.
So why does he say that? If it has momentum, it has mv, it has to have kinetic energy because obviously the half and the square are there. You're just putting them on top of the momentum that already exists. So if it has momentum, it has to have kinetic energy. Why can't... I mean, the irony of it, right? Momentum is always usually a visible thing. Kinetic energy is the invisible one. I mean, and in this case, the momentum is the invisible thing and somehow the kinetic energy isn't, it doesn't make any sense. How can you say it has zero kinetic energy if it has momentum? If momentum is stuck in the building, then why wouldn't I say kinetic energy is stuck in the building?
Can you understand that? Can you reconcile that? Can you show me mathematically that that is completely kosher?
The part that's not kosher to me is that you now have 3 units of momentum and you started with 1. That's the real problem.
That the wall has momentum 2mv, it's non-negotiable.
It is negotiable. It's arguable. It should be argued. And physics doesn't want to have rational arguments that are kind of right there in your face. It's creating a duality and a paradox.
Must have momentum, and yet it has no kinetic energy.
So again, he says it must have momentum. Doesn't make any sense. How can it lose the kinetic energy then? If the momentum exists, the kinetic energy has to exist. So it doesn't even say anything. But the very fact that you're saying it has this momentum when it's, where is it if it's not moving?
How is that possible? Think about it, and if you can't solve it, call me at 3 a.m. and I'll tell you the solution.
So I think physicists do this crap where they don't give the answer when they think the answer is ridiculous and they're going to sound foolish. So I think his answer is, if he actually did call him at 3 o'clock, he would just scream into the phone, "You fucker, it's in the earth, you dumbass." He'd just tell you the earth moved. So whatever the building is attached to, that moved, like Manhattan moved. Okay, if it's the Empire State Building, you moved all of Manhattan, the whole landmass moved a little bit. Not argue, bullshit. That didn't happen.
Okay, now.
All right, so that's the point has been made. Okay, and now I'm going to show an example where doesn't it really say that explanation is impossible, that the Earth doesn't really move, and there is no momentum in the building, and all you did was get a reflection. You put 100 in, 100 came back out again. No big deal. Not any more complicated than that. So, the simple solution is to, just do his drawing, and I'll just add a simple little real device that we are all familiar with. Okay, so brick wall. Okay, blue ball And all I'm going to do, okay, and it's coming in with 100 momentum. And they say it created 200 this way. 200 momentums are going this way. Whether I like it or not, it's happening. Even though the building isn't moving, the energy is in that wall. And it's now moving the whole Earth. The whole Earth is now going that way with 200 momentum. That's their explanation. Alright, just tie a string to it. Okay, there. Okay, now isn't the whole thing ridiculous? Because if I do make this out of hard steel and anvil, and I do take a little steel ball and I bang it into the anvil, the fact is it's going to bounce back a lot of times. It's going to do this. It's going to bang in 200, and it's going to fly back, and then it's going to bang back in again 200, and then it's going to go back up, and then it's going to bang in again 200 more, and then it's going to fly back, and then it's going to bang in again 200 more. So do you really think that can happen? That the Earth is going to keep going, is this going to keep getting 200 momentums? So I think you could understand that the only way this keeps going all the way back, the only way I keep reflecting, is nothing can be going in here. I can't be losing any momentum to the wall. That's why this keeps bouncing back. And as soon as I let the wall yield, as soon as I say, well, the wall tipped a little this way, this isn't coming back anymore. If this goes in, if this something here moves, something here ain't reflecting. So I'd say that's a logical proof that this explanation doesn't work. It's been falsified, okay? I have falsified it. I have demonstrated it has a catch that just breaks it. Because this doesn't happen. I can't put 100 in and get 5,000 out. Can't do it. Free energy babble. Not how reality works. So that's argument one to PhysicistMichael. That's why I keep pushing this subject, is because there's lots of things being said by physics professors that just don't make sense. They don't hold true. All you do is tie a string to what they're saying happened, and all of a sudden it can't happen anymore. Alright, so for part 2, I'll be back. Alright, so I have been having a little bit of a cordial conversation with PhysicistMichael, which is much improved over the video content, but anyway, there was one part where I asked him, have you seen the ion Gostling crap? And I'm sort of looking for his reaction to the fact that this guy has titled 3 videos Proof of Kinetic Energy. And not only is the experiment really, really far from a proof, I mean, it's almost the worst example possible. I mean, I don't know how it could be much worse in terms of a proof. It's so bad. And he's just calling it a proof. And then his experimental technique seems completely, I mean, he says right in the video, I know this experiment's wrong, and I know my answer's right, and I'm going to now force the experiment to match the results. I mean, the confirmation bias is so obvious. And I was sort of looking for PhysicistMichael to say, yeah, it's obvious. He's, this isn't the kind of guy that should be doing experiments, because he's just going to try to shenanigan it. He's just going to try to make it look like, he's going to do whatever he can to tie bird feathers to it, or do whatever he can to make it come out his way. And that's it. That's his only motivation. How can I force this experiment to come? Can I tilt something? Can I bend something? Can I twist something? Can I add something? Can I do something to make it come out my way? All right. So anyway, this was his response. To respond to the question you posted, Ian Gosling's first couple of experiments had some definite issues. Well, the first experiment had an obvious issue that he did it wrong, so he didn't do it by what he thought he was doing, his own standards. And it came out ambiguous. I mean, the answer was clearly right in the middle somewhere between the two theories. and he titled it Proof of Ke Yay. How is that credible? Is that what people should do? Should I just keep saying I proved it? Every argument I make, I should say is a proof against your theory, and there's, and we'll just do this infinitum. Everybody will just say proof on their lies, frankly, on things that aren't proof. Nowhere close to a proof. The word proof should not be taken seriously. Is that your argument? I mean, come on. But he seems to be currently be considering the criticisms that have been mentioned. What criticism? He did the experiment with the wrong calculation. Okay, period, bad idea. I mean, it was 5 times the height rather than 4 times the height. Rather simple, stupid error. He corrected the rather stupid error. Nothing else was criticized, by the way, by me anyway. And the results came out exactly confirming me, proving me right. He didn't title the video Gary proven right. He didn't say momentum proven right. He didn't do any of that. He said, I'm learning. So was that honest? And then he didn't even show the experiment. So when the experiment comes out exactly confirming my prediction, exactly confirming it, so exactly that he even made the point that it kept coming out exactly the same. I mean, it was exactly my prediction. The title's not correct, and he doesn't even show the experiment. I mean, come on. You can't see. You've done 3 videos now about the credibility of experimental data and how to interpret experimental data and its credibility. You don't see anything wrong here? The titles aren't appropriate. The evidence isn't shown. How many shenanigans can he be guilty of before you say, yeah, this guy shouldn't be doing experiments? Amazing. He's way too spectrum. He's got way too many. His spectrum panties are showing. And frankly, I'll point out, he's got obviously dementia or something. Anyway, and finding ways to identify and correct those sources of error. So there was no. The obvious errors would be, okay, the clay gets a little too manipulated, but frankly, how much can it matter if your results keep coming out consistent? So I commended his efforts. I don't know, did you commended his efforts in this case? You commend somebody for saying proof of, and it doesn't not even close. The answer's so far off. He's only taking, he's created an artificial, 7% error, okay, to claim my theory's now 7% off. His theory is still way the hell off. It's I'm full magnitude more percentage off. Okay. All right. Just amazing. So I commend his efforts and look forward to seeing how his experiments might improve. So he didn't even see the experiment that's supposed to be so bad that it's 100% off because it proved me right. We don't even get to see it, let alone critique it as being somehow broken, even though he admits he did it over and over and over again and it came out the same way every time. It sounds like it's a pretty credible experiment. All right, I'm currently in the process of grading papers. Okay, so we won't bother with that. Let's see. Well, maybe I should bother. Let's see. I tell my students. Oh, okay. No. All right, whatever. I mean, this whole idea of doing amateur experiments is just, I don't know why a scientist would say, yes, the amateurs should do brain surgery. I don't know why a scientist would say this is good ground for good physics. No, it's really toxic ground for really bad physics. Alright, so let's go to the Gosling's most recent video. Alright, so here's the video. So here's the first video where he dropped it from 5 times the height rather than 4 times the height and celebrated because he got an ambiguous answer right in between the 2 predictions. So he calls it proof of kinetic energy, yay, when he didn't prove anything except you can't do the experiment very well because he confirmed neither theory, and one of the two theories we have a pretty high likelihood is correct, and one of them is incorrect. Anyway, so he figured out, well, he didn't figure it out, I pointed it out, nobody else did, of course. Every time it seems I have to find the errors, nobody else does, okay? So, an obvious error. So he does it again, completely confirming, and all he says here is, so he did proof of KEA, the end is nigh, so somehow he thought the error was somehow in his favor, that somehow if he fixed the error it was going to way improve his answer and he was going to prove kinetic energy. So he says the end is nigh. I mean, you approve of this rhetoric. He's got a decisive proof. He can call somebody else wrong or stupid or ignorant or some other name based on this absolute shit as evidence. So anyway, so this experiment that he doesn't show us, the experiment, he just demonstrates how it came out. And it tells us how it comes out. And it completely confirms that I'm correct. My prediction is 100% confirmed, and we don't get to see the experiment. And he just says something like learning all the time. And now in this video, he clearly states, yeah, it's time to break the experiment. I'm going to force the experiment not to match. So right in this experiment, he actually says the words, I know this answer's wrong, and so all I have to do is tie a pigeon to it and everything's going to be okay, because I'll find a way to break it. Alright, and so he does. He glues a whole bunch of crap, extra crap to the thing, and then breaks the perfect results. So it was doing the perfect thing, which it perfectly matched my theory. At least it perfectly matched one of the theories, let's just say that. And now he's just going to tie shit to it until it stops matching. And that's it. That's all we have. And now he says, let's design a better apparatus, and he wants to use a spring instead of clay, because all of a sudden clay doesn't work. And they have a whole theory that somehow clay isn't basically a suspension, and that it's really duplicating, kind of like Galileo's ramps are allowing gravity to happen but slowing it down. Clay is pretty much a liquid that's really sluggish. And theoretically, it really does provide a rather consistent resistance to the fact that it's going to take some deformation. It's going to move. And it'll move pretty regularly. So there's no theory that clay is actually bad at this. But he says clay doesn't work because it came out my way. So he wants to get rid of the clay. Now the irony is, okay, that we can go all the way back to this end is nigh. End is nigh. So he did this video, and right in the video he says, come on Gary, you weak ass piece of shit. Go ahead, tell me what your prediction is, because I got this experiment's going to prove you an asshole. And so I give him my prediction with the one tiny qualification, which is, well, over the last couple of weeks we've kind of figured out, at least I figured it out, that when you're dropping something in gravity, you not only have the momentum you're creating by the motion, but you have the actual weight of the object. The actual weight of the object will also be in the energy. So even if it's a meteor hurling through space and it has 500 million foot-pounds of pressure, it also has the weight of the meteor. Okay, it's going to be tiny, right? Infinitesimally small, but it really does have to be subtracted from the actual motion. The gravitational weight, the constant force, gravity, is still there. So obviously when you're dropping these weights, you're going to also have the weight of the weight. Okay, so it might weigh 300 pounds when you drop it. You have to subtract the fact that it's only a 10-pound object. Alright, but anyway, not a big deal, but anyway. So he found that catch too offensive and said, I'm not going to do the experiment because you put a catch in it. Because all he was going to prove was that somehow it didn't come out exactly the same. Okay, so when you drop the half mass 4 times the distance, all he's saying is all I have to do is prove that it's a tiny bit off, and I proved Gary wrong. That's his whole ambition. He's not proving kinetic energy right, he's just trying to prove Gary wrong. I mean, it's so obvious. And here you won't say the words that this guy has completely the wrong temperament to be doing physics experiments? I mean, it is just amazing. So here was the experiment I thought, let's play this one just for the hell of it. I mean, I thought this video he was going to do the experiment. I also believe he already did do the experiment. So we have a bolt. So he has clearly already attached this thing to a rather rigid object. So why would he do all of that and never drop the weights? So I thought the idea was he's going to have clay on here so we get a permanent reading of the impulse energy, and he would just drop, obviously not 5 pounds because it's, he's only got a 6 kilogram scale. So obviously if you're going to be dropping stuff, you're going to be, 1 centimeter doubles its weight. So you can't be, you have to drop things that weigh in the ounces. You can't be dropping things that weigh in the pounds, because you're going to be in big trouble if you drop them any amount of distance. But anyway, you just drop the weight and you see how far the little spring compresses, and it tells you how much energy it had at full extension. Now obviously you need a good piece of wire or something that doesn't stretch, blah blah blah. So you do have to do some thinking here. But anyway, and so he weaseled out of doing the experiment. Okay, he just weaseled out of it. For whatever reason, because he knew my prediction was probably correct. Why else would he weasel out? He'd already done the experiment. He knew my prediction was correct. All right, anyway. So the part that's just incomprehensible, I mean, I just can't come anywhere close to understanding how this guy could have anything other than dementia, is that he makes this new video talking about using a spring and talking about, why doesn't he just drop the weights? I mean, what sense? He's talking about using a lever when we're arguing about whether levers are even conservative at all. So if levers don't conserve the energy, what's the point? I mean, if they don't conserve momentum, that's what they're arguing, that levers don't conserve momentum. I mean, even in the 50-50 case, they can't be doing it, because how can they know the difference? Anyway, so, all kinds of problems here. So why didn't you just do it? So he's talking about putting this wire inside the copper, all kinds of bullshit. You're saying, why is he bothering with any of that mush? Why doesn't he just hang the spring and drop the weights? Drop one of them, the same thing. Drop one a foot, drop the other one 4 feet. 4 foot of string. One of them only has 1 foot of string, and one of them has 4 feet of string. It'd give you a rough idea anyway. I mean, maybe it wouldn't be perfect. I don't see how it could fuck up much, but who knows? I mean, I didn't really think about it much. But you don't need guide wires or anything. Just tie the weight to a string. Right? I don't understand. It's the same experiment he was supposed to be doing before. Why is he talking about like he just invented the idea? It just doesn't make any sense. I can't make any sense out of this video. It's complete nonsense. Anyway. And you're defending this. You think these people are doing science. And it shouldn't be pointed out that no, they're really just, these are religious type creationists. I mean, they're trying to find a way to force a dinosaur footprint on top of a human one. They're just trying to find a way, okay, to fake the evidence. And the fact that you won't admit that, I mean, and to me, it's it's a little bit of a smudge on your credibility that you can't see through this crap. You can't. Proof of kinetic energy, yay. And the answer isn't even, the experiment is, again, almost as far as you could possibly get from a proof. You couldn't define it as a bigger failure to prove. Okay. So, yeah, maybe I'll leave it at that. I don't think there probably is something else I wanted to get to, but this is probably enough of a video, but we'll see. I have a third subject, maybe. Alright, yeah, I'll just throw in this one little comment since it's on the wall thing, so we might as well throw it in there. So this is what? Fizber Saucerer. I guess that's supposed to be Cyber Saucerer. Okay, whatever. The wall yielding isn't a problem. So again, what do you mean it's not a problem? If I'm trying to get the ball to bounce off the wall, I'm saying you really think it's going to bounce back just as much if the wall is moving? If the ball's impact causes the wall to move, you think the ball's going to bounce back the same amount? I mean, come on. As long as the yielding is exclusively elastic. What the hell does that mean? I mean, it doesn't mean anything. If the ball moves, its movement isn't elastic or inelastic. Movement is, you know, the what comes before you call it elastic or inelastic. But clearly, elastic is pretty much saying it doesn't move. I mean, in the sense that the ball bounces off of it. All right. So elastic deformation. The yielding is exclusively elastic deformation. So what's being deformed? The ball is doing the deforming. So let's understand the spring is built into the ball. So we might as well just think of it as a croquet ball or something with a spring on it, and we happen to be really good at throwing it, and the spring hits the wall between the croquet ball and the wall. So if the wall yields, it breaks, it does anything. I mean, how does the wall elastically deform exactly? I mean, the argument is it's a brick wall. It's not going to elastically deform, so it's not going to store and release energy or any of that kind of crap, at least in a substantial way. I'd argue that the energy goes in and it gets reflected inside the substance, but, you know, so there, you could call that deformation. But that wouldn't be movement of the wall. So again, if the wall moves, it means that it didn't store it. It means it's not reflecting it, and it means it absorbed the energy. If the wall moves, it absorbs the energy. It clearly can't reflect the ball anymore. So I don't understand how you could type this sentence. Just mush. So frankly, I want to delete it because I'm not going to go to the trouble to explain it to you personally. I have read it, and I think I have appropriately pointed out how you're just talking shit. You're just glibly stepping into the conversation with a sentence that really doesn't have anything to do with the subject. If I throw something at something and the something moves because I threw it, I'm not going to get 100% reflection too. That's not going to happen. Ever. Okay. Try again. Alright, so that's probably enough of a video. Yeah. I just keep thinking there was some other point I had, you know. Anyway, it doesn't matter. Okay, we'll just call this a video. If I need to make another one, I'll make another video. Alright, till the next time and such, and so forth and whatnot. This has been a DraftPhysics.com, DebatePhysics.com also. But, we have to narrow the subject, frankly. One subject at a time kind of thing has to be done. So vector versus scalar, and vector meaning subtractable energy, whatever that would mean. Yeah. Is there such a thing as subtractable energy? Unenergy.